Today we're going to be talking about relations and functions. There is a lot of new vocabulary in this lesson, so get ready to take some notes. You'll refer to it a lot. Okay, so first of all, you need to know what a relation and a function, what those two things mean. A relation is just any set of ordered pairs. So two variables have a relation to each other. So we're going to have ordered pairs, x and y. Set of ordered pairs, that's called a relation. For example, these age-height pairs could form a relation. So giraffes, their age and their height, they have a relationship to each other. You could write those as ordered pairs, just by doing the xy coordinates like 18, 4.25, etc. So it doesn't have to be written in ordered pair format, but that is an example of a relation. A function is a special type of relation. It's a relation that assigns exactly one output or range for each input or domain value. So every time you have a certain x, maybe we could also add that in, the input, the domain values, those are represented by the x coordinates. The output or the range values, those are represented by the y coordinates. Okay, so every x coordinate, if there's a certain x coordinate, it has exactly one y coordinate that goes with it. So I'm going to show you one way to identify whether something is a function. So A here, we know that's a relation because it's a set of ordered pairs. And I want to know if it is a function as well. So I'll show you what a mapping diagram is. A mapping diagram, we usually have two, I like to call them just like little eggs, ovals, something like that, where we identify our inputs in one and our outputs in the other. It's usually nice if you try to order them least to greatest or something. You don't necessarily have to do that. For this first one, let's just go straight in order. So I'm going to say my input, those are all my x's. So I've got 4, I've got 2, I've got -3, and I've got another 2. Okay, but I don't want to write the second 2 again. I already have it in there. It's one of my inputs. Okay, for my outputs, I'm going to have 3, -1, -3, and 4. And now when I map it, I'm going to say, what do each of these things go to? So the 4, it goes to a 3. This 2 goes to a -1. Draw an arrow there. This -3 goes to a -3. And then the other 2, which is still on there, goes to a 4. So if we look back, I'm just going to flip back to the last side. I'm going to remind you that a function is a relation that assigns exactly one output range for each input domain value. So you can see here that the input 4 has one output, but the input 2 has more than one output. So because of this 2 right here has more than one output, we would say this is not a function. Okay, it's just not a function because the input 2 has more than one output. It goes to both -1 and +4. Let's look at another one. Try this one on your own and then come back and check with me. So, -4, 0, 2, 12, -1, -3, and 1, 12. So this would be, and I'm going to map this. Conveniently, my inputs are already in order. So I'm going to say they're -4. Oh, actually, they're not. 2, I thought it was a -2. It threw me off. I'm going to put them in order this time. It's -4, -1, 1, and 2. And your outputs, I'll put those in order too. It's -3, 0, and 12. Okay. And I'm trying to figure out what they go to. So I'm going to look here. And -4 maps to 0. 2 goes to 12. -1 goes to -3. And 1 here goes to 12. Okay, so you're going to notice that this one is similar to the last one, but a little bit different. If you look on the left at our inputs, each of them goes to exactly one output. Even though 1 and 2 both go to the same output, 1 only has one output and 2 only has one output. So because each of those inputs has exactly one output, we are going to say that yes, this is a function. Okay, so that's the difference. I sometimes get confused about what a function is when I'm doing this method, so I really like this next thing called the vertical line test. The vertical line test says that if any vertical line, so remember that's up and down, wide of the sky, passes through more than one point of the graph for some value of x, the relation is not a function. So I'll show you what that means here. So we're going to look at this example. We're going to determine whether the relation 3, 0, negative 2, 1, 0, negative 1, negative 3, 2, and 3, 2 is a function. So what we're going to do is first plot those points. Okay, I'm trying to go quickly, so I've already done this in advance, but you should plot those points on your paper and then come look what I do. Okay, so on the left here, you see that I've graphed these pairs on a coordinate plane. And that's the first thing you need to do. Then step 2, you can pass a pencil or visualize or, draw lines through. But you're putting vertical lines across your bar. And what you need to see is, does it ever cross more than one at a time? And I'm going to see that yes, here at 3, 0 and 3, 2, it crosses more than one point. If it passes them both in the same vertical line, it is not a function. Okay. All right, so let's try this one. You try this one on your own, and I will also plot it out, and we'll check. So we're going to graph these points, and I want to see if it's a function. So 3, 2, 5, negative 1, negative 5, 3, negative 2, 2. Okay, so if I'm looking at a vertical line, I might be able to see it. Let me just make a vertical line really quick. That if I pass this through, every time it passes one point, it only passes one point vertically. If I had done the horizontal line test, you could see that it would pass those, two of them at the same time, but that's not what I'm going for. So this one is a function. The vertical line test passes. So yes, it's a function. Okay. All right, we're going to look at some new notation today, and I'm going to talk to you about how to evaluate functions and look at those. So you're going to hear us talking about a function rule in class. Me and your classmates will be talking about a function rule. A function rule is it's an equation, and it describes what's going on in a function. Again, we've got lots of vocab here. The domain is the set of input values. So everything that you're inputting, usually your x's, you put them in some sort of equation, you evaluate the function rule, and here out comes the output. Those are usually your y values. They're also called the range. Domain is input, range, output. The output values always depend on the input values. So we're going to look here in the equation y equals 3x plus 4. What variable is the input? So you should notice usually the variable that's all by itself is going to be the output because that's what you're solving for. So x is the input variable here, and y is the output. If I ask you to create a table of values that fits the function for this, you're allowed to pick whatever value you want for the x, and then you need to solve it for y. So again, I did this one in advance because I knew I'd be running out of time. I started with a little function rule and said, hey, x is my input, y is my output. Hey, if I throw in a certain value for x here, what am I going to get for y? And I happened to see that when I inputted x for 1, I did 3 times 1 plus 4, that's 7. I got my output. When I put 2 in, 3 times 2 plus 4 is 10. When I put 3 in, I got 3 times 3 is 9 plus 4 is 13. So I got this table to the right. And you can pick whatever values you want, depending on the situation. They have to make sense. Okay, this is usually the trickiest. I know there's so much new information in this. So like if you need to take a pause, run, do something else for a minute, I get it. Just pause and then come back so you can process everything. So function notation. A function is in function notation when you use this. It looks like f parentheses x. Usually you'll see it in one line, but my spacing got messed up. So usually it would look like this. F parentheses x to indicate the outputs instead of using y. But we don't call it f parentheses x. It does not mean f times x. We call it f of x. Okay? F of x is it said f of x, like I just said, and it does not mean f times x. That will throw you off. It's often common to say h of x or g of x or maybe h of n, or lots of different variables could go in there. Those are common things. F of x, it's just one variable. It's your output. Okay, it means the same thing as like y would. So it's just one way of expressing y. I want you to look at this little chart, and it's going to be important to know. When we're dealing with a function, everything that's on the left side kind of has a similar meaning. They go together. If I'm asking you what your domain is, that's your input values or your x's. If I say range, I'm looking for your output values or your y's, and f of x is also an output or a part of your range. Okay, so if I ask you to solve something like this, make a table for f of t equals 0.5t plus 1, and I ask you to use 1, 2, 3, and 4 as domain values, I'm going to go ahead and do this one. So our two variables this time are t and f of t. F of t is one variable like y would be by itself. And so what I'm going to do is I'm going to say 1, 2, 3, and 4 are my domain values, so I'm going to plug them in for my t's, my inputs, and then I'm going to evaluate this function for f of t. So basically all I'm doing, I'm saying f of t equals, in the first case, 0.5 times 1 plus 1. So 0.5 times 1 is 0.5 plus 1 is 1.5. So I'm saying for the very first one, f of t equals 1.5, so I'm going to put that there. Now you've seen me work one out, I'm going to kind of mentally do the rest. 0.5 times 2 is 1 plus 1, so it's 2, then 2.5, then 3. Okay, so this is my function table. Not really different than what you've done before, except you'll see f of t. Okay, so another common one, evaluate the function rule f of g equals negative 2g plus 4 to find the range for the domain negative 1, 3, and 5. So again, I'm just plugging in negative 1, 3, and 5 for g. So I'm going to do f of negative 1. That would equal negative 2 times negative 1 plus 4. I'm just plugging it in, so 2 plus 4, that would be 6. If I do the same thing for 3, do negative 2 times 3 plus 4, it's negative 6 plus 4, that would be negative 2. And for 5, I'm going to do negative 2 times 5 plus 4, and that's going to be negative 10 plus 4 is negative 6. And so it looks like when I've evaluated it, my range, it's 6, negative 2, and negative 6. I'm just putting it in the same order that how I evaluated it, but often you might see that least to greatest. Okay, so last thing, and then you can process it a lot and we'll practice it. If f of x equals 2x squared minus 5, you're going to, these are not negative signs, these are just the way I use my bullets. I want you to find f of 5, f of negative 3, and f of 1. What f of 5 means is that 5 is substituting in for your x. So 5 is the value I want you to solve this for. So f of 5 equals 2 times 5 squared minus 5. I'm going to follow my order of operations. 5 squared is 25, times 2 is 50, minus 5 is 45. Okay, so f of 5 equals 45. Try the next two on your own and then check them with me. So f of negative 3, that would mean 2 times negative 3 squared minus 5. So 2 times 9 is 18 minus 5. I should get 13 for this one. F of negative 3 equals 13. And then the last one, I'm going to substitute 1 in for x. So 2 times 1 squared minus 5. I do 2 times 1 minus 5 is 2 minus 5 is negative 3. F of 1 equals negative 3. All right, so functions, relations. You might want to go back and review your notes before class, or maybe even watch part of this video again because it's a lot to digest. And I will see you in class.